Good afternoon, dear students, and welcome to our today's online class. We are discussing about extraction of metals, and we came to know that in the extraction of metals there are different steps involved, and they are mining, through which we get ore, crushing and grinding, concentration of ore, roasting and calcination, by which we concentrate the ore and reduce the concentrated ore into their metallic oxides. The next step comes reduction, and finally we end our extraction of metals by refining process. We have already discussed about mining, crushing and grinding, concentration, and roasting and calcination. Now in our today's class we are going to discuss about reduction and refining. So let us start our today's class. Now, conversion of concentrated ores to their oxides, which we did in our earlier class, can be done by either roasting, and roasting is done with sulfide ores, and calcination. Calcination is done to ores of carbonates and hydrated ores. Roasting is the strong heating of ores in the presence of air, whereas calcination is the strong heating of ore in the absence of air. And by both the processes we can convert concentrated ores to their metallic oxides. Now once these metals are converted into their oxides, metal oxides, now we need to remove that metal from the oxide, from the oxygen. So we need to free metal from oxygen, and that is how we get pure metal. So that process is done by another step, which is known as reduction of metal oxides to their metals. Now reduction of metal oxide to the metals can be carried out in two different ways. They are chemical reduction and electrolytic reduction. So again, metal oxides can be reduced to the metal by these two different ways, and they are chemical reduction and electrolytic reduction. Now let us understand first chemical reduction. Now this chemical reduction is carried out to those metals which are moderately active and lies in the middle or lower position in the activity series of metals. So this chemical reduction method is applied to the metal ores or metal oxides which are moderately active or less active. Example: zinc oxide, iron oxide, copper oxide, silver oxide. So these are moderately or less active metal oxides, and they can be reduced by chemical reduction method. So in this method, metal oxides are reduced to the metal by heating at high temperature in the presence of reducing agents such as carbon monoxide, or hydrogen. And among these three reducing agents, carbon is the strongest reducing agent. So therefore, by heating these moderately active metal oxides in the presence of reducing agents, we can get metal from the metal oxide. For example, zinc oxide, when reacts with carbon, when treated with carbon, and when they are heated at high temperature, we get zinc, solid zinc, and carbon monoxide gases produced, which escapes in the air. Similarly, iron oxide, when treated with carbon monoxide and heated, we get solid iron and carbon dioxide gases formed. In the same way, when copper oxide is reduced by using hydrogen and heated, we get metallic copper along with water vapor which escapes in the air. So this is how we reduce metal oxides of moderately active or less active metals to their respective metals by using reducing agents. Now let us see another method, that is electrolytic reduction method. Now oxides of highly active metals which lies at the top of activity series of the metal are generally reduced by electrolytic reduction. So we carry this electrolytic reduction to those active metals, metal oxides, which lies at the top. For example, oxides of sodium, potassium, calcium, magnesium, and aluminium. For this oxides of these metals, we follow electrolytic reduction to get metal from their metal oxides, and we will specially focus on oxide of aluminium in our this syllabus. Now, these metals, due to their very high affinity towards oxygen, forms very stable oxides. So like aluminium oxide, alumina, this is very stable oxide. Why? Because aluminium has very high affinity towards oxygen, therefore it combines with oxygen very easily, and the oxide which it forms is very stable, as a result of which normal chemical reduction method cannot reduce this metal oxide into their respective metal. So we cannot reduce aluminium oxide to get aluminium by using reducing agents such as carbon monoxide or hydrogen. They need more energy. Hence we follow electrolytic reduction. Now, the electrolyte used in the electrolytic reduction of metal oxides is, we normally prefer fused or molten metallic salts. Metallic salts can be either in the form of halides or oxides, for example alumina. And the electrodes over here are made up of, cathode is usually made up of iron or carbon lining. There is a mistake over there, iron or carbon lining. So cathode can be made either of iron or of carbon. And anode is usually made up of graphite rods. So these are the two things which you have to know while doing electrolytic reduction. The reaction at the electrodes. So at the cathode, what type of reaction takes place during electrolytic reduction? So normally at the cathode, cations move towards cathode, CC relation. I hope you remember. So metal cation at the cathode gains electron and converts into neutral metal atom. For example, aluminium gains 4 aluminium ions gains 12 electrons, because the valency of one aluminium atom is 3, so 4 aluminium will gain 3 4s are 12 electrons and will convert into neutral aluminium metal atom, and that gets deposited at the cathode. While at the anode, the non-metals migrate, anions migrate towards anode and they get discharged over there. So anions, they lose their electron and they convert into neutral atom. For example, during the electrolytic reduction of alumina, at the anode, oxygen migrates towards anode, oxygen ion, oxide ion, and they gain electron and finally convert into, first they convert into nascent oxygen. Nascent oxygen means the atomic form of oxygen which gets formed during the reaction. Now this nascent oxygen cannot exist independently. Therefore, more nascent oxygen atoms, they combine with each other to form neutral oxygen molecule. And this oxygen molecule gets liberated at the anode. So these reactions you have to understand, and you have to know how to write these reactions. Reaction at the cathode as well as reaction at the anode. Now once the metal is being extracted from their metal oxide, now we go to the final stage of extraction of metal, and that is refining of the metal extracted. Now the reduced metal obtained after the reduction of metal oxides sometimes contain some residue impurities, leftover impurities. Therefore, it becomes very important to remove this residue impurities also in order to get pure metal. Residue impurities can be the presence of other metals and non-metals like silicon and phosphorus, or some unreacted oxides and sulfides of the metal. So these residue impurities need to be refined, and these refining can be done again by any one of the following processes, and that includes either by distillation, we can remove this residue impurities to get fine refined metal, or it can be done by liquefaction. Liquefaction means if the metals have different melting points, then the metal mixture containing pure metal as well as some impurities, they are heated in a slanting container so that the metal having low melting point first melts and slides down the container, and that can be collected in separate container, which will be a pure metal, or by electro refining, again by electrolysis, which we have discussed in our earlier class also. And we will specially focus on electro refining, because after this we will be learning or discussing about extraction of aluminium from its ore. So these are the important steps involved in the extraction of metal from their ores. Now once the metal is refined by any of these processes, the metal which we get is considered as pure metal, and which can be used for its different purposes. We end our today's class over here, boys. I suggest you to go through your textbook also to get more information. For today, based on today's learning, there is an assignment number 10. Question number 1. State why aluminium is extracted from its oxide by electrolysis, while copper, lead, iron are extracted by reducing agents such as carbon, carbon monoxide, or hydrogen. Question number 2. Write the chemical reaction taking place at the two electrodes during the reduction stage in the extraction of aluminium. This much for today, boys. Until we meet next time, stay safe and do all things well.